Welcome to Energy Safety Canada's Building Capacity to Manage Pressure online course. This program is a result of a creative sentencing project in partnership with the Alberta government and an oil and gas well servicing company. You will complete 3 modules as part of this course. 1. The incident review, which you are watching now, is a 3D recreation of the events that led to the death of an oil and gas worker. 2. The Understanding Pressure interactive module will introduce you to the concept of pressure and its dangers. And the Understanding Human and Organizational Performance interactive module will enable you to apply your knowledge of how humans and organizations perform in real-world environments. It was early on a warm summer morning on August 3rd, 2017, near Veteran, Alberta. The day crew on a coiled tubing rig were preparing the BOP for fracking. Unknown to the day crew, pressure remained in the BOP and piping from pressure testing the night before. The pumper operator opened the valve on the pumper to direct any water pressure to the tank on the pumper truck. Then the pumper operator gave a thumbs up to the rig manager to indicate that it was okay to proceed. The rig manager then directed the coil tubing operator to position himself on the platform, located adjacent to the BOP. The rig manager then used the BOP controls to release the test bar. The test bar shot up, striking the coil tubing operator in the head and neck, fatally injuring him. How did this tragic incident occur? The Veteran Alberta fracking site consists of several pieces of equipment, including the wellhead with the BOP, the coil tubing rig, a pumper truck, a valve manifold, and the piping connecting them. The BOP uses several rams to enable personnel to seal the well if well control is lost. When the pipe rams are tested, a test bar is inserted. The test bar has a stopper at the bottom to prevent it from being pushed entirely out of the BOP. The top of the wellhead and BOP is accessed from a platform on the coil tubing rig. The rig is equipped with 2 BOP controls. The first is located on the side of the rig, and the second is located in the cab of the rig. A variety of controls are in the operator cab that aren't available on the outside of the cab, including panels that display the pressure at the BOP. The pumper truck uses a pressure transducer at the pump outlet to measure the pressure in the piping. A blue light indicates when the pumps are operating. The valve manifold consists of 4 valves actuated by an operator using a valve bar. These valves direct the flow of fluid through different sections of the rig piping, including the pumper truck, the coil tubing rig, and the BOP. A pressure transducer is located in the piping that connects to the BOP. This pressure transducer measures the pressure in the piping and displays it inside the cab of the coil tubing rig. 5 people are required to operate this equipment: 2 pumper operators, 2 coil tubing operators, and a rig manager. The night crew was conducting a pressure test with the shear rams engaged. They opened the valves to establish a flow path between the pumper and the BOP. Then they attempted a low pressure test, but the pressure did not hold. So the crew decided to conduct a high pressure test, but there was still a leak. Unsure of the leak's location, the crew installed an additional valve to isolate the valve manifold as a potential leak source. The additional valve was installed next to the valve manifold on the piping section going to the BOP. A pressure transducer was located between the new valve and the BOP. The crew pressured up the line to low pressure levels with the new valve open and closed it after the line had been pressurized. The pressure in the line held, which indicated a successful pressure test and identified the adjacent valve on the manifold as the source of the leak. The night crew then conducted a successful high-pressure test. At this time, the crew turned their attention to the pipe rams. They inserted a typical industry test bar into the BOP that was longer than needed for this specific BOP. With the line pressurized, they closed the new valve and confirmed the low pressure held at the BOP. They then bled off the pressure and pressurized the line to 24.1 megapascals. Similarly, they closed the new valve and confirmed that the pressure held, indicating a successful high-pressure test. When the day crew arrived, the night crew quickly briefed them on the issues and that they had been resolved. All that remained was to depressurize and remove the test bar. The new valve was mentioned, but no formal documentation for the new valve was provided. 3 critical errors occurred during this exchange. The night crew did not depressurize the equipment before the crew change. The day crew did not walk the line, as is typical when transitioning equipment between crews. And finally, the day crew did not conduct a safety meeting, as the plan was for everyone on the site to have one safety meeting when the fracking crew was ready. When the day shift crew assumed control of the rig, the pumper operator bled off the pressure by opening the valve on the pumper. Another operator then opened and closed the manifold valves to verify there was no trapped pressure in any of the piping. However, the operator did not check the new valve that had been installed by the night crew, which remained closed with 24.1 megapascals of pressure trapped between it and the BOP. At this point, the pumper operator gave the thumbs up to indicate the all clear to proceed. The rig manager pointed to the coil tubing operator to get onto the coil tubing rig platform to remove the test bar. The rig manager proceeded to the BOP controls outside the unit. However, the controls on the outside of the unit were not equipped with a pressure gauge display. The coil tubing operator proceeded to leave the platform and climbed onto the BOP, placing him directly in the line of fire of the test bar. When the rig manager opened the pipe rams, the released pressure caused the test bar to rapidly shoot up and fatally injure the operator. What can we learn from this tragedy? There are several actions that can be taken to prevent future fatalities of this nature. Procedures for operating equipment must be detailed and include specific instructions for verifying zero pressure, for example, from within the cab of the coil tubing rig. a method to remove the test bar to ensure workers remain out of the line of fire, the procedure to communicate and manage changes to the equipment configuration, for example, the insertion of a new valve, the exact process for shift changeovers, including what details must be communicated and the acceptable state of equipment at the changeover. In addition to these procedures, the following best practices are recommended. Ensure all equipment is depressurized at shift change if the equipment is not being operated. When there is a change in work activity or scope of work, incoming crews should always walk the line to assess the state of the equipment and the path of fluid or gas prior to beginning work. Pressure displays should be conveniently located where safety-critical controls for the pressure are provided. Equipment should be designed with line of fire in mind. For example, test bars should be unable to exit the top of the BOP. The most effective way to ensure you can apply the learnings from this incident is to reflect on it in relation to your own work. Where and when are you vulnerable to the hazards of pressure in your work? How could trapped pressure and line of fire hazards occur in your work? How are you ensuring critical tasks are being conducted as planned? What can you do today to prevent a similar tragedy? To learn more about what you can do to prevent a pressure-related incident in your operations, enroll in Energy Safety Canada's Building Capacity to Manage Pressure online course.